Alright, hello everyone. It's February the 16th, a little bit late. I have to finish the book today because it's due, and then I did. I think I spent like 5 or 6 hours on the book today, so it's a bit draining. I feel a bit tired. So, let's get to this letter tile possibilities. Oh my god, look at the total length is 7. You have n tiles where each tile has one letter printed on it. Return the number of possible non-empty sequence of letters so you can make using the letters printed on those tiles. So isn't that just a permutation? Permutation that handles the no repeats, right? Because if you have AAB, right? If you have AAB, then you have right total number of possible. So you have 0, 1, 2. And you can have 0, 1, 0, 2, 1, 2. But each one also has reverse. Right? 1, 0, 2, 0, and 2, 1. Right? And then you have all the 3. You have a 0, 1, 2. Of course, you have 0, 1, 2, 0, 2, 1. Okay, so combination wise, we can use bitmap. And once we get bitmap, how do we get different combinations? Not combination, permutations. How do we do permutation? We get all the permutations, and then so we have an A, so we get all possible permutations, and then we'll insert A at different positions, right? So all possible permutation, and then we have another A, so we say all possible permutation of B, the last one. You know what? I can do that. Maybe we should do that bottom up. Permutation, you say. So at this first position, it's just empty or A. 2 possible, right? In the second position, I can say it's basically this one I put in the front to put it at the end. So it's going to be A, right? And then there's going to be AA. That's 2, right? So all possible for AA. And have empty. So over here, empty functions first. So this is B. So look at here. So I have B, I have AB, BA, I have BAA, ABA, and AAB. Right. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's try that. We do have to create a string though, and then we need a Okay. Oh. I don't know what happened. How do I create an ordered set? I can do that, an ordered set. Okay. Then what? Then we will say, what's the previous? So we say std vector pre, and each one say 4. So for each one, I'll get a new vector temp and temp. Oh, I can do two things. It's going to be empty string and then t. So I put 2 in it. And then after I put 2 in it, and then we just need to go from the pre. So 4, we say std string p of pre. So for each pre, we need to insert. Okay, so string insert. There is an insert function. Insert position 0, 1, 2, 3, 4, 5. So this is at the end. All right. Actually, I need to check examples. 0, 1, 2, 3, 4, 5, 6. 6 is Q. Wait, it's not position. It is position. Oh, put this one. Wait, why you have the parentheses? Oh, this is to show you where you insert. I see. 0, 1, 2, 3, 4, 5, 6. So you will insert at the 6th position. Okay. What's this? Sub position is sub length. So it's replaced in. I only do 2 positions. It says 3 and then 4. Yeah, so basically in string 3, 0, 1, 2, 3, and I take length 4, so it's just a not. And I'll insert at position 6. Okay, makes sense. So now I have this, so we just need to get the position in, right? I will insert at every single position. So for int I 0, I smaller equal to p dot size I plus plus. For each position, I can say scene dot add or insert p, right? Dot insert position and t. Titles, there's no title, tiles. Which one? Yeah, it is insert. Another set is insert. Then where do we get it wrong? P is a string. P have insert as well. I think I know the problem. We have two string this thing. It's a char. There you go. All right, and then I like to say maybe that's it. Right? We create, and the first one I add these. And pre is empty, so I don't have any pre. And Cinda insert. I mean, this thing will keep growing, right? Will keep growing, but I guess it's okay. Ah, that is a thought. Maybe don't look into the previous one. Just look into everything that has happened so far. All possible permutations happening so far. Then why do you need scene? Why do you need a pre? Right? Yeah, it's all the possible permutations, and you are just adding to it because that's exactly what it says. You just do permutation. Non-empty sequence of letters. Right? It doesn't matter. So that means I don't think we need this anymore. I don't think I need this anymore. Right? And I don't think I need this. I don't think I need this. I think for string s of scene, Ooh, does it even allow to do something like this? Holy crap. It might not even allow because I'm actually I see. I see your concern. Okay, so I see your concern. So I get a temp out. That's fine. And then I'll say temp pushback. Okay, we temporarily stores in this. So this is going to be seen. So you take everything that's in it, right, and then we insert into this, and then I'll put everything, say for std string t of temp. We can say scene dot insert t. Okay, and at the end we'll return scene dot size. All right, this is kind of how I'm trying to figure this out. Create all possible permutations. It should be factorial. Ooh, something is not right. Memory exceeded. Really? How? How much memory you are allowing me to use? Really? Okay, I'm very surprised. Huh. Yep, I don't think we can do that. Oh, this is bonkers. What the hell? I mean, if you want to print debugging, you might as well just debug this. I'm just curious. 65. Huh? What the hell is this? What the actual hell is this? New str. strt. Okay, tstr. Okay, and then we can call this tstr, right? Then we'll insert str temp.pushback new str. Don't use this. Alright, I cannot believe it. We have to debug this again. All right, let's take a look. Let's see. Does everything work as we intend? All right, anyway, so we start. Oh, wait, hold a second. What happened? Cannot move. What? Oh, I think it's dead. Shoot. Are you good? Okay, we're good now. No, we're not good. Hold on. Where are the values? Things are not right. Hold on. Things are not right. I'd like to quit this commenting again. Okay. Oh, I think I know why. I pressed the wrong button. Press the wrong button. I'm supposed to be pressing F2, but I pressed F3. Alright, so T, we start with A. Huh. Okay, that's not right. Alright, it's just still char to string. Okay, now use to string. What do we use then? std string. Huh. So it's not to string. Hold on, let me cancel. It's not to string. It's just string. No matching. TSTR. Maybe it should be this, right? Yes. So now we have a TSTR. Okay. Let's build this. I don't know, we can run it. Oh, yep, does not look good. That does not look good. Okay, TSTR. So we have std of temp. Temp has two values as expected, and then nothing So we'll add this. That's good. Yep. Okay, so scene has 2 values. Okay, that makes sense. Next is A again. Alright. So template on this again. So for each one, I equal to 0. I smaller than P. P is A. Now this should be AA. Oh, it does not create a new one. It's changing the, oh wow, that is not what I want. String insert new string. You have to create a copy. Shoot. So we have to create a copy. Okay. We have to create a copy. How do we create a copy? String copy. Okay, I'll just do that directly. Fine. So we need to copy it. Basically, every time the scene, right, we need to create a copy, and then we need to push back the new string. That is actually not bad an idea. We can say string new is equal to P, right? And then we can say this will be new dot insert. Oh, probably cannot use new. New str. Alright, insert I and a tstr. So we don't need this. Okay. Let's try this. Okay. This one looks much better. Let's try it. Yeah, it's more of just, oh, I need a -1. Do not count empty string. We can use reset test cases. Yeah, so basically it's not really hard. It's just how to, I have 2 pieces of knowledge I don't know. One is this string insertion is in place. That I do not know. And the second is how to turn char into a string. I was using toString, but toString actually turns it into the ASCII number version. So these 2 is kind of really got us. Let's see. 2 pieces of info that I did not know before. Number 1, toString char will not produce a string of the char, but rather the string version of the ASCII of the char. To create a string of char use string std string char. So that's one. And number two, the insert function of string changes it in place, right? Thus, we need to create a copy and then do the insertion on a copy. The runtime is going to be, complexity is O(n) factorial. Okay, you want to try, let's try another one, like try this, and let's try A, B, C, D, E, F, G. 1, 2, 3, 4, 5, 6, 7. Okay. Just go through this, see how it works. It works pretty nice. So we can submit. Might not be the fastest because it's really, you know, straightforward permutation. I didn't really optimize it at all. It looks like there is a way to optimize it. Yeah, for sure there is a way to optimize it. I guess there is a way. I don't know how to optimize it. At least not right now. We can read the tutorial, not tutorial, we can read the editorial and then see how to optimize it. For example, if we want to optimize it, I'm just thinking like if you find repeats, can you try optimize if you find repeats? I don't know. That probably will make things more complicated. All right, can we optimize recursion? This is just, it's the same idea. Optimize recursion. Instead of tracking individual letters, we can track the frequency. Okay, I did not track the frequency. Frequency of the letter. So basically we get, in this case, we have ABC. But frequency, what does the frequency do to us? Basically says for every of, let's say we have all the combination of B, C, right? We can have 1, we have 2, we have 3, and then we'll sprinkle this 3A around them. And that basically means if we have a single B, right, then we can create 3 position here and 2 position and 1 position, 1 position, 2 position, and 3 position here. And for each one of them, you can put all, it's the same because they are the same. And we can do this for B, we can do this for C, we can do this for BB, we can do this for BC, and then we can do this for CB. So how many different ways to do this? And of course, if you have like a BB, right, you will open up more positions. And again, you can have 3 positions here, and then you can say, okay, 2 positions, 1 position, 1 position. Then we can do this, then we can do this, and then this again. That is a thought. how many different ways we can do this? Instead of thinking how many different ways, we can just say we have 3 positions, and how many ways can put these in, right? So basically, it's 1, 2, 3, 4. 4. So it's permutation. 4 position we permute 2, right? Because I can put BB here, right? B and B here. Oh, but it does not allow to have BB on one side. I feel like that's a special case. Oh, it also doesn't allow them together. Oh, wow. Somebody predicted this. Okay, I need to read this. I'm still thinking like my method of doing it. Putting things around. Putting things around. Putting things around has this downside. Let me think. You can say, because we have these repeats, you can say all of them together we can put, right, at 3 positions. Or we can break it down into 2, right, into 3. You know, that feels just complicated. All right, optimize recursion. Frequency of each uppercase letters. Find sequence. So we have the frequency. Try using each available character. So we go through this. We find a character we can use. Add current character and then recurse. Well, we can add a current character count, and I will find. That is simple. What the hell? That is very simple. Huh? Wait. Wait, what? So basically this is saying, given the current state, which is just a count of each letter, right? And what I do is I go through them, we find one, and then we say every time we find one, we just plus plus. And because I use one, now I have the remaining. And the remaining can give me the total number of sequences, right? And then I just add it. I just added. Hold on. let me think again. So we have a letter. Let's say we use it. Okay, we use it. And then we have the remaining. And I say, okay, I get all different combinations, not combinations, all different subsequences for the remaining. And then they are based on the current one coming out, right? Which means I can say they will all combine with the current one. So that's why you add them. And then you'll do plus plus. It's like backtracking. Huh. Don't quite understand the logic behind this. What really matters isn't the position, but rather how many of these each letter we have available. Whether we use the first, second, doesn't matter. We just need to know we have 3 A's to work with. That is correct. That's the state. Instead of tracking individual letters, we can track the frequency of each letter. Separate piles for each letter. 3 tiles of A, 2 in B, and 1 in C. And maintain. Okay, this is fine. How we build a sequence using these frequency counts. At each step, we're asking ourselves, which letter should I add to my current sequence? We can loop over all 26 letters and use any letter that still has a positive count. This is fundamentally different from our we were making yes or no decision. For many letters suggest the recursive, we will pass this to the recursive. So we're saying we'll use one of this letter, okay, and then you tell me how many in total. For the next state, right? And how does that help us? Each unique sequence determined by the number of letters available, not the sequence. Yes, I understand what it's trying to do, but I couldn't wrap my head around. We say the total number of sequences determined by the frequency. I agree, because it doesn't really matter exactly what you are. What matters is giving the current state, which is the count of each letter. You give me the number of total sequences. So when it's A, right? So AAB is A has 2, B has 1, right? So if I say I take 1A, right? So now what I have is A is 1, B is 1. Now for A is 1, B is 1, I say I'll take an A. So now I do is A is 0, B is 1. So I take a B, and that's it, because I keep going, it doesn't give me anything. So now this one will give you 1, which means under this situation you have only 1, right? You have only 1. And what I say right now is, because we're looking at this 1-1 situation, so I say if I take A, because the total number of sequences, right? So I say I can do A, or I'll do whatever the remaining. So basically, because a B is a 1, so I say I can just add that. I don't know what that means, because now you return. Or you can take B. Oh yeah, you say I'll return, so basically this is gonna be AB. Whatever it is, I put A in front. Or I'll take B, right? Because B has 1, I'll take B, and then whatever returns will become BA. So this is, we add 1, add 2, right? Add 3, add 4, so this is plus 4. Now we go back to the previous level, right? And then previous level can say I will add that. So basically now we have as A, AA, AAB, right? AB and ABA. It's like we're starting from A. What's the total number? And then we just add it to it. And because it's fine, we all start with B. Alright, we start with B. Now B just become AA. Right, AA. So the next level, A will be 2, B will be 0. So I can take an A, now we'll go to A is equal to, this is the one just gave me A. So this one will have A and AA. Right, so plus 1, and then come to the top level, that's going to be BA and then BAA. So that's the total answer. 1, 2, 3, 4, 5, 6, 7, 8. Ah, I see. So basically, we're saying each number can be the starting position. Exactly. So we'll go through every one of them once. If that is the starting position, give me the remaining, the total count, and I'll just put it. Oh, that's actually pretty smart if you think about it. I actually like this method a lot, because you don't have to keep track of the sequence. This method is inspired by method 2 of the tutorial, editorial. The key observation is that you can use a frequency counter to represent the state, right? The state of the tile when one tile is used. When one tile is selected as the first tile in the sequence. We go through all the tiles, right? We'll go through all the tiles to serve as the first tile, and recursion to compute the total number, right? The total number of sequences in the remaining tiles. Okay, this is pretty smart. So I start with a vector of int, call it 26. I would say for char t of title, and I call it counter, right? I say counter t minus a plus plus. Right, this is our counter. Now counter is done. We need a recursion int called helper. So all we need is just a counter. right? Counter is the state. Okay, so this one will count as the state, and this function returns the total number of sequences that can be created based on the state described in counter. Right? That's essentially what it is. Now for this counter, we just go through every single one. So for int I 0 I smaller than 26, I plus plus, right? Well, I have int rest equal to 0. In fact, it should be 1. So we can always, actually no, I should just do 0. Right? I say if counter I is larger than 0. Okay. Now we say rest plus plus. Right? This one is use the current letter by itself. Right? Or after that, I can say counter I minus minus, and then rest or plus equal to helper counter. Right, so this is find a number of sequences without counting, without the current letter, right? Without current letter, and then prepend the current letter to each sequence. That's what it means, but we don't really create the sequence, right? We don't really create the sequence. So now after we're done, so we need to backtrack to do counter I plus plus, right? Because we remove it, we find everything, and then we do this. And at the end, we return rest, right? Which means if everybody has been used, so we don't go through this, and we just return a 0. Sounds reasonable to me. And I can just say return helper counter. Why you can't constantly say titles? It's tiles. Okay, now let's try this and see if it makes any sense. Addition of unsigned offset. We have an overflow, I think. Huh. Where? Oh, here. It should be a capitalized letter. It's not lowercase letter. Wow, this is a solution. Yep, this is the solution. Oof, this is a solution. I think the runtime, the complex is 2 to the n, but this one scores the limit. It's 2 to the n because at each position, no, that 2 to the n is just the total number of permutations. Is 2 to the n, I think. Right? No, that doesn't sound right. So the recursion basically saying that I will do the current and I'll do the remaining. Right, and the second one, Then all the remaining. The third one is the remaining, right? Actually, I'm not sure. How do you come up with 2 to the n? For each character in the input string, we have two choices: either use it in our sequence or not. We either use it or we don't use it. And this to me is like you always use this. Anyway, well, I'll let it slide because really I can't think much at the moment. All right, that will be it. I'll see you guys tomorrow. Adios.